Good evening, everyone. Hello, everyone. Yeah. Yes. Mm, Great. So now, good evening. Good evening, everyone. Can you guys confirm am I audible? Please comment yes in the chat. Great. Hmm. Great. Okay. Great. So, guys, the agenda of today's session is about pointers. Okay, we will be learning about pointers, reference variable, some basics of array. Okay, and the in-depth array we will be covering in the DSA bootcamp essentials. But yes, we will be learning about the basics of array, and after that we have dynamic memory allocation and static memory allocation that we are going to learn in the today's session. Okay, everyone. Yeah. So without wasting time, because we have only 1 hour 30 minutes, okay. So let's start the session, right? And about attendance, about certification, that guys you can ask at the end of the session. If you have any questions related to the class, right, related to the topic, you can write in the chat. Okay, I'm happy to answer. Great, great guys. So in the previous session, we have learned about variables, right? We have learned about data types. We have learned about primitive data types. We have covered 4 to 5 primitive data types and how they are getting stored behind the scene, how the memory is getting allocated behind the scene, and how the data is getting converted from the decimal format to the binary format, or from the character format to the binary format, right, everyone? That we have seen in the yesterday session. Okay, great. So guys, in the yesterday session, we have discussed about the derived data types also, right? We have started with the derived data type and we have discussed about the functions and how the executions happen in the function. That also we have discussed, okay? About the syntax part of function, what is function, we have discussed in the yesterday session, right? So in the today session, we will be discussing about pointers, okay? We will be starting with the pointers and after that we will move forward, okay? So let's start with the pointer, okay? Pointer. Okay, great. So guys, anyone, what is pointer? What is pointer? So pointers are what? Anyone in the chat? So let's start with a simple example and after that we will cover the definition, okay? What is pointer and why we need pointer, everything, okay? So here, if I am declaring a variable and initializing at the same time, okay, let's declare a variable here, that is int I is equal to 10. So here what I have done, I have declared a variable I, right? And the data type of I is what? Integer, and it is storing this data 10, right? So guys, yesterday we have seen two things happen behind the scene, right? First is what? Memory gets allocated to this variable int I, right everyone? Memory gets allocated. Can you guys write in the chat how much memory will get allocated to this variable I? How much memory will get allocated to this variable I? 4 byte, right everyone? 4 byte will get allocated to this variable I because it is of integer data type, right everyone? After that, we have seen what? We have seen that data gets stored inside the memory block, right? Data gets stored in memory, right? That is, the decimal data gets converted to the binary data, right? We have seen in the previous session. There is one more thing happen behind the scene, guys. That is, there is an entry that gets created here, right? So here, what is happening with these two steps here? If I have this memory, right? This one here. So in this memory, we have this 4 byte, right? This 4 bytes will get allocated to this variable I, right? Yes or no? And here we have discussed about the address, right? Address is in hexadecimal format, right? So here, if the starting address is 700, right? So here, like this. So here we have one entry point, right? We have one entry point where corresponding to the variable name, this 700 get mapped, right? This 700 get mapped. So this I is pointing to this 700, right? That is clear, everyone. And the data type, what kind of data it is storing? It is storing integer kind of data. So this entry will get created behind the scene for you, right, everyone? This is clear. Okay. Similarly, if I am declaring one more variable, that is int j is equal to 20. So again, 4 byte will get allocated to this variable j, right? And let's assume the starting address is 800. Okay. So again, our entry gets created here. That is j is a variable name and corresponding to j, 800, right? Yes or no? Corresponding to j, 800 will get stored in the table here. And what kind of data? Integer kind of data. There is a lot of different information that gets stored behind the scene. But yes, we have to use these three information. So we are focusing on these three information, right? This is clear. And this table is called as symbol table, right, everyone? This table is called as symbol table. That is clear. Yes, everyone. So here, when I am printing the variable I, right? When I am printing the variable I, so what happened behind the scene? So first, when I am printing the variable I, so here it will go to the symbol table. It will check whether I is defined or not. Yes, I is defined in the symbol table. Yes, I is there in the I is present in the symbol table. So it will go to the corresponding address, right? So the corresponding address is 700, right? So it will go to this particular address, and from this particular address, now it will see the data type. Here we have int, so int occupies 4 bytes. So from 700, it will read 4 byte of data. And what is present, whatever is present inside this 4 byte of data, right? It will fetch those 4 byte and it will convert those 4 byte into the decimal format, and we get the output on the output screen. That is clear? Yes or no? Okay, again I am repeating. Okay, so here what we are doing, we are declaring a variable and initializing at the same time. So what happened behind the scene, guys? We have the memory that get allocated, right? 1 minute. Yeah, here, right? So 4 bytes will get allocated to this variable I, right? And there is some address assigned to the memory block. Let's assume the address is 700, right? These two things happen behind the scene. This we have seen in the yesterday class, right? There is one more thing happen behind the scene. That is entry gets created. That is corresponding to this variable I. Here we are storing the corresponding address. That is I is pointing to this 700. The data present in the I is present at this 700 memory, right? Memory address. So here, this table is called as symbol table, right? So when we are printing the data I, so first it will go to the symbol table. It will check whether I is present or not. Yes, I is present. So it will go to the corresponding address, that is 700. And here, what is the data type? The data type of int I is integer here, right? The data type of I is integer here. So from 700, it will read 4 bytes, right? And whatever data is present in this memory block, it will fetch the data, it will convert the data to the corresponding data type, and it will print the data on the output screen. Everyone is getting the point. So here 10 is stored, right? 10 is stored in the binary format, right? So let's assume 1010 dot dot dot, right? So this is stored in the binary format. So it will fetch the data, it will read 4 byte, it will fetch the data, the binary format data, and after that it will see the data type, that is integer. So it will convert the binary format data to the integer type, and this 10 will get printed on the output screen. Now this is clear? Yes or no? Now this is clear? Yes, clear? So now I want the address also, right everyone? I want the address. I want to print the address on the output screen. So in order to print the address on the output screen, we will use this ampersand symbol. That is this and after that I, right? See out ampersand I here, right? And this will do what? It will go to the symbol table, and from the symbol table, it will fetch the corresponding address. So here, what will get printed? 700 will get printed on the output screen for this particular line. Everyone is getting the point? Okay, everyone is getting the point. So here also, if I will run the program here, you can see guys, right? Let me remove this part from here, right? So here, int I is equal to 10. We are declaring a variable of integer type and we are assigning 10 data to it, right? And after that, int, okay, let's print the data, right? That is C out ampersand I here, right? This one. And ampersand I will do what? It will go to the symbol table and it will fetch the corresponding address and it will print the address on the output screen, right? So this one here, and here let's print the data, right? That is C out I, right? And Endel here, right? Everyone, this one. So Endel is used to move to the next line, right? If you have to print something on the next line, you can use this keyword that is Endel here, right? So let's run the code now. So guys, you can see what we are getting on the output screen. That is Cout I, 10 is getting printed on the output screen. And the next line, that is line number 8, is printing what? It is printing the address of I. Right, everyone? It is printing the address of I, that is this one. And you can see, guys, this address is in hexadecimal format. Right, everyone? This is clear? Please give a thumbs up in the chat if this is clear. So in order to print the data present in the memory block, use the variable name. In order to print the address corresponding to the memory block, use ampersand I. Right, everyone? This is clear? Yes. So now I have to store the address also. Basically, why we store the data, guys? Why we store the data? So that we can process the data according to our problem statement, according to our use case, right? Similarly, in some problem statement, we have to process the address also, right? So we have to store the address somewhere, right? We have to store the address somewhere. And there comes your pointer. Okay, there comes your pointer. So pointer is what? Pointer is a variable that stores the memory address of another variable. Okay, so here pointer is what? It is a variable that stores memory address of another variable. That is clear, everyone. What is pointer? Okay, so here now I have to store this ampersand I, this address, right? I have to store this address inside a variable. So for that we need a pointer, right? So here int star, we have to use int asterisk, and after that the name of the pointer here, right? That is here, this is the name of the pointer, right? Name of pointer here. Int asterisk p, you can use any name. Here I am going with p, is equal to, this pointer is used for what? It is used for storing the address of another variable. So ampersand I, right? This part will give us the address corresponding to I, right? And this address we are storing inside a variable that is your p of pointer type, right? So here, if I have to read this line is what? If I have to read this left line, this is p is a pointer to an integer, right? Anyone? P is a pointer to an integer, right? Anyone? This is clear now. Okay. So now what happened? So here, let's assume, let's create a simple program, right? Okay. Let's create a simple program here, right? That is int main, right? And after that, we have to write some code here, right? So here, let's assume we have a variable I that is storing 10 inside it. And after that, we are creating a pointer of an integer type, right? And this pointer is storing address of I, right, everyone? This pointer is storing address of I. So here we are using this int. Why we are using int? Because we are storing address of integer type. That's why we are using the data type as int. That is very important. Okay. So if someone is asking you hey, what is this int star p? So you have to say, okay, this p is the pointer that is pointing to an integer, right? That is pointing to an integer. That is clear. Okay, great. So now, right? So int star p is equal to address of I. And after that, here, right? What will happen behind the scene? Let's see that also, right? So here, when first line will get executed, 4 byte will get allocated for this I because I is integer data type, right? And this 10 will get converted to the binary format, and this 10 will get stored inside this memory block. Let's assume this is 700, right, everyone? After that, we are saying what? We are saying int star p is equal to address of I, right? So I address is what? 700, right? So we have executed the right hand side part. Now we will go to the left hand side part. In the left hand side part, we are declaring a pointer, right? Pointer to an integer, right? So this will also occupy some memory. So basically, pointer occupies 8 bytes in most of the compiler. It depends on compiler to compiler, but yes, most of the time it occupies 8 bytes in the computer memory. So here 8 byte will get allocated. 8 byte will get allocated to this p here, right, everyone? So in the symbol table also, you have a I, and corresponding to I, 700 is stored, and you have p, and corresponding to p, this let's assume the starting address is 1020. So 1020 is stored here, and this pointer is storing what? It is storing the address, that is 700, right? This pointer is storing the address. That is clear. So if I will write cout I, guys, what will get printed on the output screen? Please write in the chat. If I am writing cout I, what will get printed on the output screen? Yes, everyone. I am audible? Yeah. Correct. 10 will get printed on the output screen. That is a very simple question, right, everyone? Tell me, guys, what will get printed on the output screen if I am writing cout ampersand I? Now, what will get printed on the output screen if I am writing cout ampersand I? Ampersand I. Now, the address will get printed on the output screen, right, everyone? Ampersand I is what? It is fetching the address corresponding to I. So here, the address of I is what? In our example, the address of I is 700. So 700 will get printed on the output screen, right, everyone? Similarly, if I will ask you, hey, what will get printed on the output screen if I will write cout p, right? Cout p. If I will write cout p, okay. Again, you can see inside p, this p is what? This p is representing 1020. So inside 1020, what is stored? 700 is stored. So 700 will get printed on the output screen, right, everyone? This is clear? Yes or no? This is clear? So here, let's create a pointer, right? That is int I is equal to 10. Int asterisk p is equal to ampersand of I, right? And after that, cout I, cout address of I, and cout p, right? This one here. Let's see what output I'm getting now, right? Okay, I've done a mistake, so I have to write this semicolon, right? Okay, good. So you can see, guys, right? For I, we are getting 10 on the output screen. Address of I is this one, and the P is storing the address of I. So both the values are same here. That is clear. That is clear, everyone. So if you are given the address, okay, if we are given with the address and we have to fetch the value, this address is given to us. Let's assume this address is given to us, okay, this one here, and I have to fetch the value stored inside this memory block that is pointing to this particular address. So what we will do, we have to dereference the pointer, right everyone? We have to dereference the pointer. So how to dereference the pointer? So if I like this, that is cout asterisk p. So asterisk p is what? Asterisk p is what? It is dereferencing the pointer, right? It is going to that particular address and it is reading 4 bytes because of integer data type, and it is fetching the value and it is printing the data, right? So dereferencing here, right? This one here. Let's see again what output I am getting now. This one here. Done. Again, I am getting 10. That is clear. So star p is what? It is dereferencing the pointer. That is, it is going to the memory address that is stored inside the pointer, and after that it is fetching the data from that memory block, right everyone? This is clear? Yes. Great. And you can see guys, this one, right? You can see what is endl. Endl is to move to the next line. Okay, if you have to print something on the next line, you can see, right? First I'm printing 10 and after that I'm moving to the next line. So if you have to move to the next line, you can use endl. Okay, why use pointer if we have and? And is what? Okay, see, so here Komalpreet has one question, right? He's saying, Komalpreet is saying, okay, why we are using pointer when we have ampersand? Tell me why we are using variable. Why we are using variable when we have the data in front of us? Tell me, Komalpreet. So that we can reuse the data, right? So that we can reuse the data. You're getting the point? Similarly, why we need a pointer? So that we can reuse the memory address. You're getting the point? Yes or no? So that we can reuse the memory address. What not understood? Which part, Satvik? Which part you are not able to understood? And endl is what? What is endl? That I told you, right? Yes, that is to move to the next line on the output screen. Here you can see, right, 10, and after that, if I have to print the data on the next line, I will use endl, right? That is clear. Yes. Okay, Satvik, please write in the chat which part I should repeat. Okay. Till that time, I'm moving to the next part of the session. Okay. Yeah. Great. So now here, and let's see the size also, right? If I have to see the size of the pointer here, that is this one, cout size of p, right? So basically we have to use the size of function and it will give the size of the variable. Okay, so here we want the size of this pointer, right? So I am using the size of, and inside this I am enclosing inside this p, right? So here and endl, right? This one. Let's run the code now. So you can see guys, we are getting the size as 8, right? We are getting the size as 8. Dereference part I have not understood. Okay, so here let me repeat the dereference wala part again. So here what is happening? Int I is equal to 10. So 4 byte is getting allocated behind the scene, right? Let's assume the starting address is 700. Okay, and let's assume we have the symbol table here. And in this symbol table we have I, and corresponding to I we have 700. After that we have int star p is equal to address of I. That means 8 bytes will get allocated behind the scene for this p pointer, right? And let's assume the starting address is 1020, right? So here p, right, and corresponding to p 1020 will get mapped, right everyone? Corresponding to p 1020 will get mapped. And what we are doing with the pointer, we are storing the address of I. So 700 will get stored here. After that, cout I will do what? Cout I, first it will go and check in the symbol table. I is present, yes, I is present. So it will go to the 700 address, and this I is of integer type. So from 700, it will read 4 bytes. because I is of integer type, right? And whatever is present in the memory block, it will take the data, it will convert the data to the decimal format, and you get the result 10 on the output screen. And after that, if I am doing cout p, right? Cout p. So here it will again go to the symbol table. It will check what is the memory address corresponding to p. So 1020, right? And since this is a pointer, right? Since it is a pointer, so from 1020 it will read 8 bytes. And what is present inside this? This memory address is present. So it will take the memory address and it will print the memory address on the output screen, right? After that, cout star p will do what? Here we are dereferencing the pointer. That means we will go to the data that is present inside the pointer, that is present inside the memory block, right? So here p is pointing to 10, like the memory block allocated for p is what? 1020. So it will go inside this 1020, and from here it will read the data. What data is present? 700 address is present. So it will go to 700 address, and whatever is present here, it will take the data and it will print the data on the output screen. So here what is present? 10 is present. So 10 will get printed on the output screen. You are getting the point? Yes, Satvik, now this is clear? Yes. Okay, great. So let's move to the next part. Can you guys please give a thumbs up if this is clear? What is pointer? How thing is happening behind the scene? Right? Yes or no? So let's move to the next part. That is pointer and function now, right? So yesterday we have seen what is function, right? Pointer and function. Okay, great. So here, let's take example, right? Let's take example here. And with the help of example, we will be learning about pointer and function, okay? So here, if I'm taking 1 minute here, right? So this one. We have the main function, right? Int main function. And inside the main function, what I have done, okay, I have declared a variable I, and this I is storing 10. And after that, int asterisk p is equal to address of I. That is, we have declared a pointer p, and this pointer p is storing the address of I, right, everyone? That is clear. And after that, here, right? Here. And after that, let's assume I have created one more function, that is void increment, right? Void increment. And here, this increment function is returning nothing, and it is expecting this int star p, right? Int star p here, right, everyone? And after that, what we are doing? We are doing p is equal to p plus 1. P is equal to p plus 1, right? P is equal to p plus 1 here. And after that, we are calling this increment function, that is increment. And here, we are passing this p, right? We are passing this p here. And after that, we are printing this one, right? Cout p, right? We are printing cout p here, right? So guys, please write in the chat what will get printed on the output screen, okay? And you have to make assumption this I is like the memory for this I is that 700 memory address, right? And the memory for this p is at 1020 memory allocation. Okay, so like this you have to imagine, that is, you have memory allocated for this integer I, that is 700, right? And 700 is the address, starting address of the memory block, and it is storing 10. And you have memory allocated for this pointer, and the address is 1020, and inside this 700 is stored, right? So what will be the output? Cout p. What will be the output, guys? Please write in the chat. Everyone, let's see who all understood the concept of pointer now. Everyone, only 2 answers. Okay. Ramesh, you are very close to the answer. Okay. So here you can see, guys, right? This line is clear, right? That is int I. Okay. No, not correct answer. No one has given the correct answer till this point. Okay. So here int I is equal to 10. That is clear, right? 4 byte is getting allocated behind the scene, and the memory address, the starting memory address is 700, and after that this pointer, that is also clear. After that we are calling a function. Calling a function means what? From this line you will directly go to this point, right? You will directly go to this point here. And what you are passing inside the function, you are passing this p. P means what? Inside p, what is stored? 700 is stored. So you are passing this 700, right? So this 700 will get stored inside this variable, right, everyone? This 700 will get stored inside this variable. So here we have this increment, right, function, and inside increment function, what you are doing, guys? This is main, right? This is main function. Inside increment function, what you are doing? This, you are defining a parameter, right? Defining a parameter means what? It will occupy some memory. So here, what kind of parameter you are assigning? This is a pointer. So pointer will allocate, pointer will allocate how much memory? It will allocate 8 bytes behind the scene, right? This is p, right? This is my p for the increment one. And inside this, what we are storing, guys? We are storing 700, right, everyone? We are storing what? We are storing 700. After that, what we are doing? We are doing p is equal to p plus 1. Right? So first right hand side part will get executed, right, everyone? And in the right hand side part, what we are doing? We are doing p plus 1. So the value of p is what? The value of p is 700. So it will take, let's write the address also, that let's assume 2050. Okay, the address of this p is 2050, right? So inside p, what is there? 700 is there. So it will take this 700, right? Plus it will do 1, right? But here, what this 1 means? What this 1 means, everyone? So this p is pointing to which kind of data? This p is pointing to integer, right? P is a pointer to an integer. Integer occupies how many bytes? Integer occupies 4 bytes, right, everyone? Integer occupies how many bytes? Integer occupies 4 bytes. Yes, everyone? Yes or no? So here, this 700 plus 1 means 700 plus 4, right? That is clear. Because we are dealing with address here. We are dealing with address here. That is clear. Okay, let's see on the this one also, that is here, right? This one here, right? Okay, great. So here we have what? We have a increment function, that is increment, and this increment function is accepting this int star p, that is one pointer, and after that what we are doing? We are doing p is equal to p plus 1, right? And after that return. Okay, since we don't need to return anything, so let's take void here. And after that, here what I will do is I will declare a variable int I is equal to 10, and after that I will take a pointer, that is int star p is equal to address of I, right? Address of I. And after that I will call this increment function, right? That is increment, and I will pass this p here, right? And after that, what I will do, I will print this p, right? Let's see what output I am getting now. Okay, let's print the value before this also, right? That is cout and p here, right? And let's see the value now. P, okay. Yeah. So here you can see, guys, first thing is what? Both are same, right? Both are same here, right? So if you will try to print here, then you will get 704, right? Here, that is this one and this one here, right? This one and that here, right? So let's see now. This one, and after that this one here, right? So let's run the code now. So here you can see, guys, right? We are getting this DA870 is this one and 86C. So here 6666, and this C is representing what? ABC, right? That is 3 4. Okay, so here you can see, guys, right? It is adding 4 byte here, right, everyone? That is clear? Yes or no? That is clear. So 704, it is like 700 first, and after that it is adding 4 byte. That's why it is getting to 870 here, right? That is clear. Okay. Let's see. Yeah. And one more thing, guys, you can see, right? If I'm printing here, right, you can see this one. We are getting the same address, right? Let's see now. We are getting the same address here, right? Why? We are calling, 1 minute, not here, right? 1 minute, sorry, my mistake here. This one and this one here, right? Let's see now, run the code. So you can see, guys, we are printing the data at line number 13, right? We are getting the address. After that, we are doing the increment in the pointer. Again, we are printing the data, right? Again, we are printing the data. But again, we are getting the same result. But we have done some modification. Why the modification is not reflecting here, right? Why the modification we are not able to see here? Because you can see what we have done, guys. Whatever modification we are doing modification in this increment function, right? This 2050 address, we are going here, we are doing the modification here, but it is not getting reflected here. So here, if you will try to print cout p before the increment function call, you are getting 700, right, everyone? And again, after the increment function, again you are getting the same value because you are not doing any modification here. Whatever modification you are doing in this increment function scope, right? That is clear. Yes, this is hexadecimal, and sir, I can take type of pointer. I mean, we can change p of any. Yes, it depends. Sahil, if you are storing address of character type, then you have to take cat as your data type in the pointer, right? Similarly, if you are storing the address of float, then the pointer data type will be float. Okay, that is clear. And this part is clear. Why? In the main function, before the calling of the increment function and after the calling of the increment function, why we are getting the same value, 700 and 700. That is clear, everyone? Yes or no? Please give a thumbs up if this is clear. So why we put int data type for pointer? Because pointer is storing address of integer type, right? What we are storing inside this 700? What we are storing inside this 700? We are storing this data 10, and this data 10 is of integer type. So this pointer is storing what? It is storing the address of an integer, right, everyone? That's why the data type of pointer is integer. Yeah, that is clear. Yes, Naveen. Great. Till this point, everyone is clear, right? So let's move to the next part now. So here, the next part is what? So let's move to the array. Okay, let's discuss the array, and after that we will take array and pointer both as at the same time. Okay, so array here. So guys, anyone, what is array? Sir, the data can increment, so the memory address is changed or not. See, basically what we are doing here, Sahil. Okay, let me complete it right here only. That is what we are doing here. Before the calling of increment function, see out here, we are printing p, right? And after the calling here, we are printing p, and we are getting the same value, right? We are getting the same value because here we have this main function, right? We have this main function, this one here, right? So the stack will get created for this main function. Inside this main function, you have this I, and corresponding to I, you have this 4 byte allocated, right? And inside this 4 byte allocated, 10 is stored. After that, you have P, and P is storing what? P is storing this 700, and let's assume that memory address for this pointer P is 1020, right? And after that, you are printing this P, right? So P is right now present at which memory block? It is present at 1020 memory block. So it will go and it will fetch the data. That is 700 will get printed on the output screen. That is clear. After that, you are calling this increment P. So a new stack will get created here, right? Yeah. A new stack will get created here. That is for increment, right? And in this increment, what we are doing, we are declaring a parameter, right? That is int star P. P takes how many bytes? This pointer take how many bytes? 8 bytes it takes, right? Let's assume the starting address is 2050, right? So this P is pointing to this 2050, right? In the symbol table, this P is pointing to 2050, right? After that, what we are doing P is equal to P plus 1, but here inside P, 700 is stored. After that, you are doing some modification. So whatever modification you are doing inside this memory block, right? You are doing inside this memory block. After that, you will come out from this function, and now you are standing here, right? And this P is pointing to which memory block? It is pointing to this memory block, that is 1020. So it will fetch 700. So that's why here also 700 will get printed on the output screen. That is clear. So this is what? This is passed by value, right? We are passing the address as value, right? We are passing the address as value. That is clear. Yes, everyone. Till this point, anyone has any confusion? No, right? Okay. So what is array, guys? Okay, array is a collection of same data type. That is partially correct. Not the correct definition. Collection of similar data type. Okay, again, you guys are missing some key point in the definition. Collection of items of same data type, right? Data type stored at contiguous memory allocation, right? The memory gets allocated in a contiguous fashion in an array. That is the correct definition. That is the complete definition of array, right, everyone? Stored same data type, collection of item of same data type, right? Stored at contiguous memory allocation, right? That is clear. So here, if I'm writing like this, okay, let's write the syntax of array, that is int arr 5, right? Int arr 5. So here, what we are saying? We are saying, okay, the name of the array is arr. What kind of data we are storing inside the array? It is of integer type. And how many blocks we have? We have total 5 blocks, each of 4 bytes, right? So here, like this. And these 5 blocks are present in a contiguous memory allocation, like this. Like this, right? This one here. And here we are storing what? In each block we are storing integer. So the size of each block is what? It is 4 bytes, right? In case of integer. In case of integer, the size of each block is 4 bytes. If we are going with the character, then the size of each block is 2 bytes, right? If we are going with the float, if we have to store float kind of data, then the size is what? It is 4 byte again. For double, it is 8 byte, right? Float FRR file, right? So again, it will take 4 bytes, right? 4 bytes in a contiguous manner, right? Everyone? That is clear. And here, if the starting address is, let's assume, the starting address is, let's assume 700, right? Then this will be what? This will be 704. This will be 708, right? This will be 712, 716, and this is 720. Right, everyone? This is 720. You can see, guys, each block is taking 4 bytes. That's why the starting address is having a difference of 4 bytes. That is clear. Yes or no? And here, the first block, we have the indexing system here. That is, the first block is represented as 0 index. The second block is represented as first index. Similarly, second index, third index, and fourth index. Right, everyone? That is clear. Okay, great. So here, let's move to the code now, right? That is, we have int a5, right? Int a5 here. So what we have done, Santu, that we will be seeing, okay, whether we can do some manipulation or not, right? So here, what we have done, we have declared an array of 5 size, right? Of 5 into, like, how much, what is the size here? 5 into 4, that is 20 byte is size here, right? So 20 byte. 20 byte here. So, and that 20 byte will be present in a contiguous memory location, right? So if I am doing like this, okay, if I have to store the data, store the data, then what I will do, I will use the name. After that, the square bracket, there I have to write the index, right? Here I am writing what? 0. 0 is representing what? We have to store the data at the 0 index. So let's assume we have to store this 10 at the 0 index. And similarly, a of 1 is 23, right? Similarly, a of 2 is 89. So guys, tell me what will get printed on the output screen if I'm writing like this. That is cout a 0, right? Cout a 0. What will get printed? Please write in the chat if this is clear. Why we are not using loop? Because we haven't discussed about loop. Yes, that's why we are not using loop. The main focus is for the array, so that's why we are focusing on the array. Okay, correct. 10 will get printed on the output screen, right, everyone? 10 will get printed on the output screen. That is clear. So here, if I'm writing like this, that is ARR 0 is equal to 10. So we are going to this 0 index, and this 10 will get stored here in the binary format, right? Similarly, if I'm writing ARR of 1 is equal to 27, so this 27 will get stored inside the index 1, right? Inside the index 1. That is clear. Okay, tell me guys, what will get printed on the output screen if I will write this line, that is cout a. Cout a. What will get printed? You can see, guys, this time address is getting printed on the output screen, right? So this a, the name of the array a, is pointing to the starting address of the memory allocated to the array, right, everyone? So this a, this ARR, right? This ARR is pointing to the address, the starting address of the first element, right? The starting address of the first element. So that's why if you are doing cout ARR, right? Cout ARR. So 700 is getting printed on the output screen, right? 700 is getting printed on the output screen. And the main catch here, the main key point is here, this ARR, for this ARR, no memory is getting allocated, right? ARR is pointing to this 700 directly. In pointer, basically, if I'm doing int star p, if I'm doing int I is equal to 10, and after that int star p is equal to address of I, right? Address of I. So if I'm doing like this, what will happen, guys? 4 byte will get allocated, right, to this I. Let's assume 700, 900 here, right? 900 is the address for this variable I, the starting address, and 10 is stored here. After that, if I have to store the address here, right? Address I, what we are doing, we are storing inside the pointer, that is p here. So for pointer, first 8 byte will get allocated, right? For pointer, first 8 byte will get allocated, and here, and yes, this 8 byte is irrespective of the data type. If you have to store the address of integer type, then also 8 byte will get allocated. If you have to store the data of character type, then also 8 byte will get allocated. So this 8 byte of pointer is independent of the data type here, right? Let's assume the starting address is 1020, right? 1020, and inside this 900 will be stored, right? So here for pointer, 8 byte is first getting allocated, and after that we are storing the address of the variable I, right? That is clear. But in case of this ARR, here no memory is getting allocated for this ARR. ARR is not having any memory like this, and inside this memory 700 is stored. Not like this. ARR is directly pointing. ARR is directly pointing to this 700. Right, everyone? That is clear. That is clear. Yes or no? Pointer 8 byte is held in the stack. Yes, Naveen. Okay. But this is clear. Anyone has any doubt till this point? The difference, the first difference between pointer and the name of the array here, right? That is clear. So array is also holding this address, right? Array is also holding the address of the first block. But what is the difference then? What is the difference between array and pointer then? The first difference is for array, no byte, no memory is getting allocated. Array is directly pointing to this 700. But for pointer, memory of 8 byte, irrespective of the data type, will get allocated, and inside that memory block, the address will be stored. Right? That is clear? Yes? So this one here. So here, let's see now. This one here. That is cout A. So A is what? A is pointing to the first address of the array. How to show address? Yes, in case of array, you have to just use the name of the array, and that will give you the starting address of the memory block that is allocated to this array. And for variables, you have to use ampersand sign, right? Yes, that we have discussed about the ampersand sign. Yeah. Okay, great. So tell me, guys, what will get printed if I will write this command? That is cout. Okay, let's take the Yash question only, right? Yash is saying, okay, how to print that? So tell me, Yash, and everyone, okay, that is cout ampersand A of 0. Now, what will get printed on the output screen? In here, right? Cout. First, we are printing what? We are printing A, and this A is printing what? 700 on the output screen. That is clear. But what about this ARR? What about cout address of ARR 0? What I will get out on the output screen? Anyone? What I will get on the output screen? Cout address of ARR 0. Same address, right? That is 700 again. Yes or no? 700 again. Yeah. So let's confirm whether we are getting the same address or not. So here you can see this one here. So guys, you can see we are getting the same address, right? That is clear. We are getting the same address. That is clear. Yes or no? Okay. Tell me, guys, what output I will get. And tell here, right? What output I will get if I will print, okay, this one, that is cout A of 0, right? A of 0. What output I will get? A of 0. Correct. A of 0 is what? We are going to the address, right? We are going to this 700. Yes or no? Here you can see this cout ARR, right? Here, right? Cout. 1 minute. So here, let's assume we are printing this cout ARR 0. So basically, what we are doing, basically we are going to this ARR address, that is the starting address is what? 700, and to this 700 we are reading 4 byte. that is 700 0. That is the first block, that is 10. So 10 will get printed on the output screen. Right, everyone? 10 will get printed on the output screen. So tell me, guys, what will get printed on the output screen if I'm writing like this? That is cout star A, right? Cout star A. Please write in the chat now. Now, what will get printed on the output screen if I'm writing cout star A? Everyone. Again, 10 will get printed on the output screen, right, everyone? Let's see. You can see. Again, we are getting the 10. Why? Let's see that also. So here, this one. Let me create another memory block here, right? That is this, and this is 700, 704, 708, 712, right? 716, 720 here, right? And after that, what we are doing, we are saying 10 is here, 27 is here, and let's assume 15 is here, right? 15 is here. And after that, if I am printing cout, this is ARR, right? This is ARR, right? So cout ARR of 0. I will get the data present at the 0th index, right? 0, 1, 2, 3, 4. I will get the data present at the 0th index. That is clear. That is 10 will get printed on the output screen. If I will write cout, right? Cout star ARR, right? Now, ARR is what? ARR is pointing to 700. And this star means what? Dereference it, right? Dereference the address. That is, go to that address, go to this address and fetch the data corresponding to it, right? So this ARR is pointing to 700, and this memory block is storing what? It is storing integer kind of data. So from 700, it will read how many bytes? It will read 4 bytes. And it will take the data, convert the data to the decimal format, and it will print the data. So here also 10 will get printed on the output screen, right? 10 will get printed on the output screen. That is clear. That is clear, everyone. Yes or no? Cout is prints the content of the index value itself. Yes, cout ARR of 0 is doing what? It is going to the index 0 and it is printing the data. Okay, and star ARR is clear, everyone. This star ARR is what? We are dereferencing the ARR here, right? Dereferencing here. That is clear, everyone. And behind the scene, okay, tell me one more answer, right? If I will write cout star ARR plus 0, what I will get on the output screen? Cout star ARR plus 0, what I will get on the output screen? Everyone. Again, we will get 10, right? Again, we will get 10 on the output screen. Why? Because here you can see how it will get decoded. That is, we have this star, and after that 700 plus 0, right? 700 plus 0 is what? 700 plus 0 into 4, right? Yes or no? Basically, you are dealing with address, and for integer 4 byte will get allocated, right? So 700 plus 0 into 4 is what? It is 700 only. And dereference this 700. That is, go to this 700 and read 4 byte of data. So this 10 will get printed on the output screen, right, everyone? Similarly, if I am writing like this, that is cout asterisk ARR plus 2, right? ARR plus 2. So what will happen behind the scene? Okay, star 700 plus 2 into 4, right? That is 700 plus 8, right? That is 708. And destructure this 708, right? Destructure this part. So now, destructure this part. That is, at 708, go and fetch the data corresponding to it. That is 15 will get printed on the output screen, right? So here also, if I will write like this, okay, that is star and a plus 0 into 4, right? This one here. Run the code. We are getting the same output, right? If I will write this one, that is 2 here. 1 minute. 2 here. And 2 here also, right? This one. Let's see now what output I am getting. A plus. Why we are getting this output now? Okay, okay. 4 to the 8, right? That is correct, right? Okay, here we are not getting the same output. Which one? Mm, okay, sorry, my mistake. Okay, my mistake here. There is no need to write this one, right? So I have to directly write it, right? That is a plus 1. Behind the scene, it is happening a plus 1 into size of the memory block, right? But we have to write like this. That is a plus 2 here, right? So if I'm writing a plus 2, I will get 89 again, right, everyone? That is clear? Yes or no? Yes? Okay, great. Till this point, everyone is clear? Great. Okay, so now the first difference is what? The first difference between the name of the array and your pointer is what? For pointer, memory gets allocated behind the scene, right? Memory gets allocated. And for name of the array, no memory gets allocated, right? It directly points to the starting address of the array, right? That is clear. The second difference is between the size. That is size of pointer, that it will be what? It will be 8 byte. And size of array is what? Size of array, that is size of ARR, is what? If I am having one array of 5 size, then the size will be what? Since the integer is taking 4 byte, we have 5 block, that is 5 into 4, that is 20 byte. That is clear, everyone? So the second difference is between the size. Yes. So if I will print the size also, that is, let's see the size. That is, let's take one int I is equal to 10, right? Int star p is equal to address of I, and after that cout size of p, and cout size of a, right? Let's see now what output I will get. This one, and let's create ender here, right? This one here, right? So let's run the code now. So you can see, guys, right? For P, it is taking 8 byte behind the scene, and for A, it is 20 byte, right? It is 20 byte. That is clear. Please give a thumbs up in the comment if this is clear. Yes or no? Okay, why 20 byte? Because here you can see, guys, right? This one, this one, this one. Okay, so here, if ARR is pointing to this 700, so from 700, it will go and it will take the whole memory block, right? And it will calculate the size and it will give the size. So for here, this one, it is giving 20, right? This is clear, everyone? Okay. So now let's move to the next part, right? Size is clear, right? Size is clear, and size of, okay, size of is clear for pointer and the name of the array. And the first difference is what? Memory is getting allocated to pointer, but no memory is getting allocated to this ARR, right? It is directly pointing to the starting address of the array, right? That is clear. The third difference is, okay, 1 minute, guys, okay? This one here. Hmm. Okay, great. So the third difference is what? The third difference is between the modification. Okay. So if you are writing like this, that is int I is equal to 10, and after that you are saying, okay, int star p is equal to address of I, right? After that, you are saying, okay, let's take one more variable, that is int k is equal to int k is equal to 20, and after that int, okay, int k is equal to 20, and after that if I will take this, that is p is equal to address of k, that is possible, right? Here we can modify the data present in the pointer. That is what will happen behind the scene, like this. You can see you have this 4 byte, and inside this 4 byte 10 is stored, that is 700, let's assume, and you have this p. For p, 8 byte will get allocated, and inside this 700 is stored, right? And let's assume the starting address of the pointer is 1020, right? This is for p, and this is for I, right? And after that, we are doing what? We are declaring one more variable k is equal to 20. That is again 4 byte, and inside this 20 will get stored. And let's assume the starting address is 2150, right? This one here. Okay. And after that, we are doing what? We are doing p is equal to address of k, right? Now inside p, what we are storing? We are storing the address of k. So the address of k is what? It is 2150. So we can do the updation here. In pointer, it is possible to modify the data present in the memory block, right? But if you will try to do like this, that is the a is equal to p, right? Let's assume I'm having one array here, that is int a5, right? And if you will try to do this like this, that is not possible. A is equal to p is not possible, right? Not possible here. That is clear. Okay, let's see first, and after that I will give you the reason also. Okay, so here this one, and after that okay, this one here, and after that what we are doing, we are saying okay, a is equal to p. Let's see first this is possible or not, right? A is equal to p here, this one. One minute guys, okay. Not working. What happened? Now, right, run the code. So you can see guys, I'm getting an error here, incompatible type in assignment of this to this, right? You guys are getting the point. It is not possible for us, right? It is not possible for us to assign the address, right, inside a, right? That is clear. Why? Because this entry, right, this entry is created where? This. If you are doing this one, that is int a5, right? So in the symbol table you have this a, and corresponding to a you have the memory block. That is, let's assume the memory block is something, right? Address here, address of array, right? And it is not possible to change the value inside the symbol table, right? Symbol table. That's why if you will try to update the value of a, that is the address here, it is not possible, right? That is clear? Yes or no? That is clear. Please comment in the chat guys if this is clear. Okay. Yes. Yes or no? Okay, great. So the last, we have how much time left? We have 20 minutes left, right, everyone? So let's move to the next part. Until this point, everyone is clear, right? Yes or no? So here, one more thing, guys. One more here, right? One more part is left. That is, let's see how to pass the array to a function, right? That is, let's assume we have this int main function, right? Int main function, and inside this, what we have done, we have declared an array, of size 5, right? An array of size 5. And after that, what we are doing, we are saying, okay, let's pass this value, right? That is a function here, and we are passing this array here, right? We are passing this array here, and let's receive this array here, right? That is int function or void. Let's take void here, right? Void function and int a, right? Like this, right? This one here. And tell me, guys, what will be the output if I will try to print the size of cout, size of a here? Please write in the chat, guys. What will be the output? Everyone, cout size of a. What will be the output here? Anyone? Size of a. What output I will get here? Correct. I will get 20 byte. Right, everyone? I will get 20 byte. Here we are having how many blocks? 5 blocks, each of 4 byte. That is 20 byte. I will get on the output screen. Tell me, guys, what will be the size here? That is cout size of a. Size of a. 20 byte is clear. Why 20 byte? 5 block is there, right? 5 block is there. Each block is of 4 byte. That's why 20 byte. What about this one, guys? What will be the size of a here? What will be the size of a here? Anyone? It is not 4. It is not 4. It is 8 byte. Okay, here we will get 8 byte. That is here. We will get 8 byte. Let's see why we are getting 8 byte here, right? Let's see. That is this one. Okay. Here we are calling the increment function. Let's call the increment function here, and let's pass this a here, right? And after that, we have what? We have this a, this one here, right? And after this, here nothing, right? Let's run the code now, and let's print the value also, right? Cout size of a here, right? And let's print the value here also, right? That is cout size of a here also, right? Let's see now what output I will get. That is, let me write something else also so that we can indicate. That is inside increment function, right? And here where we are inside main function, right? That is inside main function, right, everyone? That is inside main, right? Let's see now. Run the code. So here let me put Enroll also, right? So that it is very clear to us. That is this one, and here this one here, right? So you can see, guys, inside increment we are getting the size of a as 8, and inside the main function we are getting the size as 20. Okay, why we are getting this kind of behavior? Okay, let's see that part also. So here basically where you are declaring the array, it will behave like an array. Okay, it will, this a will store 20 byte only. That is the size of the array. But when you are passing the array to a function, then it is passed as a point. It is received as a pointer, right? So here this int a behind the scene will act like this. That is int star a, right? Int star a. So it will act like a pointer when you are passing the array to a function, right, everyone? Yes or no? That is clear. That's why it is printing the size of a pointer, that is 8 byte. That is clear now. That is here. We have this 5 block, right? This one, right? 5 block we have here, right? And this is 700. So this a is pointing to 700, and because of this 700, it is going and it is taking all the byte that is allocated to the array, and it is printing 20. But when you are passing size of a to a function, then inside this function, right? Inside this function, this a is acting as a pointer, right? this A is acting as a pointer. So here we have this A, right, inside the increment function, right, inside the increment function we have this A, and this A is occupying how many bytes? It is occupying 8 bytes. And inside this memory block 700 is stored, right, inside this memory block 700 is stored. That is clear now? That is clear? Yes or no? Please write in the chat if this is clear. The behavior is clear now. Okay, no excitement in the chat. Please write in the chat, guys. Yeah. I'm assuming this is clear, right? Why 8 byte? How array is behaving when it is getting passed to a function, right? That is clear. So let's move to the next part, that is what is your static memory allocation and dynamic memory allocation. Okay, so give me 1 minute. So let me now ask some question. Okay, now you have the clear understanding of variable, about array, right? Let's do some quiz now, right? So tell me, guys, here. So first, what happened, guys? We have the source code that is compiled by the compiler, right? We have the source code that is compiled by the compiler, right? And we get the executable file that is now run, right? That is now run by the system, right? Yes or no? So here execution happen, right? So we have one compile time and one runtime environment, right? We have one compile time phase and one runtime phase. Compile time phase, and here we have the runtime phase, right? Yes or no? So tell me, guys, this: if I am having this main function, and inside the main function, if I am declaring this variable int I is equal to 10, then the memory for this I here, this one here, integer here, right? So here it is having 4 bytes. So this we are telling us at the compile time, okay, we have a variable I, and this variable I is having 4 bytes, right? That is self-explanatory, right? Because integer occupies 4 bytes. Similarly, if I'm writing ch is equal to A, then at compile time only we are saying, okay, this ch is occupying 2 bytes, right? That is self-explanatory, right? Yes or no? That is self-explanatory. Similarly, here, okay, this one. So here, int ARR 5, right? Then at compile time only we are defining the size of the array. The size of the array is what, guys? The size of the array is 20 bytes. At compile time only we are defining the size of the array. At compile time only we are defining the size of this variable I, right? That is 4 bytes, that is 20 bytes. Yes or no? Yes or no? So guys, what happened behind the scene is like this, okay? That is, we have two memory area. One is your stack memory area, and the next one is your heap memory area, right? This one. So when you program, you have written some source code, and when your program run, right? At the start of the program, some memory gets allocated, right? Some memory gets allocated for the program, for the execution, okay? Yeah. So some memory gets allocated for the program to execute, okay? For the program to execute here. And how they calculate the memory, like behind the scene, they check how many variables you have defined, how many data structures you have defined, and according to that, they calculate the memory for the program to execute. That is clear, everyone? And that memory that is given to the program for execution is fixed, right? It's fixed. So here, first point is what? First point is when program run, that is when the program starts executing, right? At that time, memory is given to the program for execution, right? Memory is given for execution. Yes, everyone. And that memory that is given is fixed. And how this is calculated? This memory is calculated on the basis of the data type you have, on the basis of the variable you have defined, on the basis of the array you have defined, plus some extra parameters that happen behind the scene, right? That is clear. The main focus point is the memory is fixed. Okay. So here, this one, that is, let's assume the system has allocated 5,000 bytes for your program to run. Okay, for your program to execute and give the output on the output screen. So you are saying, okay, you are having one variable that is int n, right? You are having one more variable that is int x. You are having one more variable that is float f, and after that you are having one more variable that is int arr5, right? This one here. And after that, let's assume you are having this one, right? Till this point, everything is clear, right? This we have, and after that, let's assume we are taking input from the user. So to take input from the user, we use the keyword cin, and after that, this operator here, and after that, we write the variable name in which variable I have to store the data. So here I am taking input and I am storing the data inside this n, right, everyone? Inside this n. And after that, I'm creating one more array that is int a and here n, right? And here. So the first thing you should keep in mind is this scene, right? So here, this input happens at runtime, not at compile time. At compile time, what happened, guys? Your syntax will get checked. Okay, how much memory should be given to the program for the execution, that will be happen behind the scene. Okay, your semantics will get checked behind the scene, right? So here, cin n, that is, you are taking input and this input will happens at runtime, right? Runtime, right, everyone? This input will happens at runtime. Okay. So Satvik is saying, what? Please repeat. Yeah, what to repeat? Okay, let me repeat it again. Okay. So what I am doing here, we are understanding about static memory allocation and dynamic memory allocation. Okay. So what we have done when we start executing the program, right? When we start executing the program, please show the program once. What program once? You can take any program, right? It can be any program, right? That is int main, and after that you have written some line of code. So I'm talking about general program. Okay, that is your general code. Okay, Satvik, that is clear. Yes. And inside that general code, what I have done, I have declared some variable and some data structure, that is your array. That is clear. And after that, what I'm doing, I'm taking input from the user and I'm storing that input inside this variable n. That is clear. And what after that, what I told you, this input happens at runtime, not at compile time. Okay. Yes or no? So here at compile time, my system know how much memory this variable n needs, that is 4 byte. At compile time, my system know how much memory this x needs, that is 4 byte again. In compile time, my system know how much memory this float need, this f need, that is 4 byte again, right? At compile time, my system know how much memory this array needs, that is 5 into 4, that is 20 bytes, right? And after that, here at this point, this is happening at runtime, so we will ignore this part. We will move to the next point. At this point, again we are declaring an array, right? Again we are declaring an array, and now the size of the array is dependent on this n, and this n value is dependent on runtime. So at this point, my compiler doesn't know how much memory this array A needs. That is clear. Please give a thumbs up in the chat if this is clear. Size of A is determined at runtime. Yes, everyone, this is clear. Okay. After that, now you can see, guys, right? So 4, 4, 8, 12, and after that 20 bytes, right? That is 12 plus 20 is what? 32. 32. Okay. What to repeat, guys? What to repeat? Like, clear, right? Just declaring some variable, and we know something happens at compile time, something happens at runtime. So when you are compiling the code at that time, this integer occupies 4 byte, that we already know, right? Similarly, this integer again 4 byte, that we know. Float 4 byte, that also we know. This int arr5, This is also like the size is determined at compile time, because here the size is given, right? 5 into 4 is 20 bytes. But here, after that, we are taking input from the user, and input happens at runtime, not at compile time. Right, everyone? Input happens at runtime, not at compile time. After that, int an. So here the size of a is dependent on n, and this n is dependent on your. This n is dependent at runtime. The value of n is dependent at runtime. So we can say the size of the array is dependent at runtime, right? So how much memory? That is 4, 8, 12, and after that 20, that is 32. Plus here at compile time, we don't know what is the size of the array. So let's assume the size of this array is 100, right? 100 bytes. We are assuming, the system is assuming, okay, the size of the array is 100 bytes. So 32 plus 100 is what? It is 132, right? 132. Plus, let's take some extra byte, okay, depending on different parameters. Let's take 250 byte. Okay, 250 byte is allocated for this program to run, right? 250 byte is allocated for this program to run. But at runtime, when you're taking the input of n, right? When you're taking the input for this n, let's assume you have taken n value as 500, right? N value as 500, right? So here the size of the array will be what now, guys? Now the size of the array will be what? It will be 500 into 4, that is 1000 byte, right, everyone? That is 1000 byte. Yes or no? 1000 byte here. And how much byte system has allocated for the program to run? 250 byte, right? So here at runtime, we are saying, okay, this array A will take 1000 byte, but according to the program, according to the system is saying, okay, I will allocate 250 byte. So here you can see, guys, right? Misjudgment is happening. And because of this misjudgment, sometimes you will get runtime error, right? So this is not a good practice. So whenever you are defining the size, right? Whenever you are defining the size, okay, then you have to define at compile time. Okay, then you have to define at compile time. So here we have two memory area, that is your stack memory area, stack memory area, and we have heap memory area, right? Heap memory area. So all the variables here, these variables, okay, these variables will get memory inside the stack memory area. This stack memory area is called a static memory allocation, right? Static memory allocation. Why static memory allocation? Because here the size is fixed. The size of the stack is fixed here, right? So that's why static memory allocation we have here. And this heap is dynamic memory allocation. Dynamic memory allocation. And the size of the stack is fixed. So it is not a good practice. It is not a good practice to define the size at runtime. Always, whatever memory you are allocating inside this stack area, you have to define at compile time. You should know the size at compile time, not at runtime. Okay, if you want some data structure whose size is dependent on runtime, whose size you want at runtime, then you have to allocate memory inside the heap, because heap is a larger memory area as compared to stack. Stack is fixed, but heap is a very large memory area. So somehow you have to define the memory inside the heap. Okay, but right now, till this point, we don't know how to define the memory inside the heap. Till this point, we know we can define the memory inside the stack, right, everyone? That is clear. That is clear. Yes or no? So here, so in order to define, okay, in order to define the memory inside the heap, we have to use a keyword new, right? We have to use a keyword new, and new keyword is responsible for allocating memory inside the heap. So whenever you have to define the memory at runtime, you have to use new keyword and always try to define it inside the heap, because tag is a fixed size, and sometimes if the memory you are defining for the array, for the data structure, is exceeding the memory of the stack, your program will not run. Okay, that is clear. So how to define the memory? You have to use a new keyword. That is, now if I have to declare a variable and I have to define the memory inside the heap, I will use a new keyword, that is new int, this one here, right? New int this one here. So this new int will do what? This new int will do what, guys? It will allocate 4 bytes inside the heap. Now it will not allocate inside the static area, right? Now it will directly allocate inside the heap, that is 4 byte. And this new keyword will allocate the memory inside the heap and it will return the starting address. Let's assume the starting address is 700. So this new int will allocate 4 byte behind the scene for you inside the heap and it will return the address 700. And where to store the address, guys? Where to store the address? Inside the pointer. So int star num is equal to new int, right, everyone? So inside this static area, we have this num, right? And how much memory for num? 8 byte, right? Because it is a pointer and it is storing 700, right? It is storing what? 700. Yes or no? That is clear. Similarly, this one, right? So now here, and always when you know the size at compile time, there is no need to define inside the heap, right? You can directly define inside the stack, right? You can directly define inside the stack. And if I am writing like this, that is int star arr is equal to new int 5, right? New int 5. So what will happen? 5 contiguous block of 4 byte each will get allocated inside the heap and it will return the starting address. Let's assume the starting address is 900. So here we have this ARR and this ARR will store what? 900 here. Now this is clear. So you can see, guys, if I am having this int x here, and after that we have an array that is int a5, and after that I have to define one array and the size of the array is dependent on this n, right? So what I will do now, the size of the array is dependent at runtime. So I will not define the array inside the static area, inside the stack. I will define inside the heap. So what I will do, I will write int star arr is equal to new int n, right? New int n here, this one. So now what will happen, guys? You can see, if I am having this stack area and if I am having this heap area, right? Stack area and heap area, right? So nx 4 byte, right? This is 4 byte, this is 4 byte, right? And after that, this is 20 byte, yes or no? And after that, we are taking input, but this is happening as at runtime, right? So here, the size of the array is dependent on runtime, right? Runtime here. So now 448 plus 20 is 28 plus some extra memory, okay, depending on the parameters. So let's assume it is 250 byte. The stack, the system has allocated 250 byte for the program to run, right? For the program to run. Now, at runtime, when you are taking the value of n as 500, right? When you are taking the value of n as 500, so you can see, guys, here, this new int, right? That means 500 into 4, 1000 byte will be allocated inside the heap, not inside the stack, right? Not inside the stack. So you are able to prevent memory overflow issue, right, everyone? You are able to prevent memory overflow issue. That is clear. So that's why if the size is not clear at the compile time, right, always try to allocate memory inside the heap. Okay. And one more part here. The memory you are allocating inside the heap will not get destroyed automatically. You have to destroy the memory. Okay. How you will destroy the memory? By using the delete keyword. So here, if you are creating a variable and you are allocating memory inside the heap, that is new int like this, then in order to destroy this I, right, it is not destroyed automatically, you have to destroy it manually. So you have to use the delete keyword and after that I. So whatever 4 byte is allocated inside this heap, that will get destroyed, right? Similarly, if you have this array that is int star arr, is this one only, right? This one only. So if you have to destroy the memory for this array, then you have to write delete, and after that you have to use empty square bracket, and after that the name of the array. So this will destroy the memory inside the heap. That is clear. And memory inside the stack is destroyed automatically when the scope of the variable, the data structure is over. That is clear. Yes or no? Okay, I have taken 5 minutes extra, but hope you are able to get the clear concept, right, everyone? Correct. Correct, Nishu. It is a programmer responsibility to delete the memory inside the heap because it is not getting deleted, right? So you again get memory full like issue if you are not deleting the memory, right? So in order to optimize the memory, you have to delete it if you are declaring inside the heap, right? Okay, great. So that's all for today's session, guys. Hope you are able to understand the complete picture, right? So in the next session, we will be starting with the OOPS, right? That is your object-oriented programming, and we will be discussing about class and object. And in that class and object, I will try to cover your control statement also. And at the same time, we will be moving toward the project also, right? We will be discussing a simple project because we have only 5 days. So, but we will be covering each and everything in that particular project. Okay, great. So here about the attendance and about the announcement. Okay, great. So here you can see, guys, right? From here, this one here, right? Hmm. You can see, guys, in the link you can get the assignment. You will get the assignment. Okay, and for the attendance you have to go to this particular link, and here this one, and after that, so this one. Okay, from here you have to mark the attendance. Okay, here you can see, guys, you will get the attendance button, right? You are not enrolled. Here you can see you will get that attendance button, and from here you can mark the attendance. Okay, and you have to mark the attendance in order to avail the certification. And apart from that, guys, we have this program that will be starting from this part, right? Let me see. From okay, from 30th of November we are having this Java plus DSA program. And you can see, guys, what we are going to learn in this program is this one here, right? Okay, this one. Okay, so complete Java we are going to learn. Okay, so here you can see the syllabus. That is what we are going to learn in the program, right? That is the basic part. And after that, each and every data structure in depth we are going to cover here, right? Here you can see, guys, right? Apart from that, here you can see the trainers who are going to like mentoring you, teaching you here, right? So those trainers are having more than 5 to 7 years of experience in the teaching department, as well as they are from good companies also, right? You can see here, and you can see, guys, here the placement also. So most of the students who are enrolled in our program are getting placed at this package here, right? And you can see the USP of our program, that is this one here, right? All the topic specific interview questions will be covered. Okay, so lectures are live, you will be getting the quizzes, assignment, notes, and everything, right? And this will be the 6 month program. Okay, not 3 month, it will be a 6 month program. And eligibility is what? Any kind of graduation you have done, okay, any kind of degree you have, you can apply to this program. And you can see the fees right now, it is 35,000, something like that. Okay, here, right? So you can cover, like, you can check to this site. Okay, you can go to this site, and the link of this site will be given in the description. So from there you can take the reference, right? Okay, apart from that, any other questions, guys? Anything else you want to ask, please write in the chat. Okay, great. So thank you, everyone. Thank you.